All right, this is the review of 8.4 and 8.5. We're going to be in the textbook. Page 478 is where we are starting with question number 2. So we have 7 raised to the negative second. We're going to write this as a simple fraction. So simple fraction just means simplified. And we're going to go ahead and since this is a negative 2, we're going to go ahead and put this to the bottom. So think about it like it's over 1. Since it's a negative exponent, we want to throw it down to the bottom to create a positive exponent. So this is going to become 1 over, now this is 7 to the positive 2. The 1 ends up there because we have to have something as a placeholder. We can't just leave it blank on the top of the fraction. So it's 1 over 7 to the second power. We do want to simplify the 7 to the second and just make it a nice number, which is 49. Okay, so don't go ahead and try and punch 7 to the negative second power into your calculator. You are going to get a decimal. We talked about how that decimal is equivalent to this fraction. This is specifically asking us for a fraction, and that's always what we're going to look for. So no decimals here. So no plugging in 7 to the negative second to your calculator. Bring it to the bottom, make it positive, and then just expand it. It's 1 over 49. Next up, 5 to the negative third. Very similar. That's going to go to the bottom, so it's going to become 1 over 5 to the positive third. Move it to the bottom. Remember, this is over 1. Move it to the bottom to make it positive and then expand it. 5 to the third is 125, so this is 1 over 125. Number 4, we have 2/3 raised to the negative first. So an easy rule here when you have these fractions is that it's just going to flip. So our final answer here is 3 over 2. Now, it's just going to stay a 3 and a 2 because this was a 1. It's negative, which flips it, but it's a 1, so the numbers don't change. If this was a negative 2, it wouldn't just flip. We'd have to do something with the numbers. So what I want to do is explore what this actually looks like. So everything inside this quotient is going to get the negative 1 exponent. So this becomes 2 to the negative first over 3 to the negative first. And then since they're both negative, we're going to go ahead and move them to make them positive. And then to the positive first, we don't have to write. And so that's how we end up here. Number 5, we've got y to the 6th raised to the negative 4th. We're going to go ahead and bring this in. So when I bring it in, this is going to be raised to the negative 24th because we multiply. Power raised to a power, we multiply. And so we need to fix this. It's a negative. Bring it to the bottom. So now we have 1 up top and y to the 24th on the bottom. Number 6. Given a fraction, we're going to write this as a negative power of an integer. So we want to rewrite this basically going backwards from what we just did. So what we need to recognize is that 36 is 6 squared. 81 is 9 squared. So I have 1 over 36. That's the same as writing 1 over 6 squared. 36 is 6 squared, 6 times 6. And if I go ahead and I put this up top, the positive exponent becomes a negative. So this equals 6 to the negative second. So I've rewritten the fraction as a negative power of an integer. Remember, integer are your whole numbers, positive and negative, including 0. Okay, so 6 is an integer, no decimals, no fractions. Number 7, similarly, this is 1 over 81. So 81 is 9 squared. And so if I want to go ahead and bring the 9 squared up to the numerator, it becomes negative, so it's 9 to the negative second. Now, as we look back here, 1 divided by 36 gives us this answer. And if I take 6 raised to the negative second, I get the same answer. Okay, so these are equivalent. Down here on number 7, if I take 1 divided by 81, I get this decimal. If I do 9 raised to the negative 2, I also get this decimal. Now you'll notice in the book, this comes out to a different answer. You're going to get 3 to the negative 4th. That was the book answer. So if we plug in 3 raised to the negative 4th, you will see it's also equivalent. So these are actually equal numbers. So there was nothing specific here in terms of what the instructions wanted. So both of these would be fine. Where this one came from is 81, instead of being written as a power of 9, could be written as a power of 3. 3 to the 4th power is 81. And so if I go ahead and bring that up, I'm going to end up with 3 to the negative 4th. Okay, but these are equivalent, so either answer is good. All right, we are going to number 11. And we got an A, B, C, and D. So let's start with letter A. We have W to the negative 1st. We're going to rewrite this without a negative exponent. So fractionally, it looks like this. We're going to take that negative exponent and move it down to make it positive. So the 1 is now on top. Not that they flipped, but this is gone. There's nothing up there. Placeholder of 1. And now this becomes W to the 1st, which is just W. So that's letter A. B. Both of these are negative. You can move them one at a time if you want, but all of this is over 1. I'm going to go ahead and just move both of them to the bottom to make them positive, so nothing is left on top, which means I need a placeholder of 1. To the bottom, it's going to be W to the positive 1, which I can just write as W, and it's going to be X to the positive 2. Okay, letter C. I put it over 1. Wasn't given as that. Notice that only the W has a negative exponent. The Y has a positive exponent. So that means I'm going to leave the Y alone. It's going to stay up there. There's no reason to move it. If I did move it, it would have to become negative. Now, W to the negative 1st, I'm going to bring that down. And that will become positive. So I have just W on the bottom to the 1st. You can write to the 1st power. That's not incorrect, but you don't have to. And letter D. So I need to identify what has a positive exponent and what has a negative exponent. I have 4 things here, my 3 variables, but I also have 5. The 5 technically has a 1 as its exponent, which is positive, meaning I'm going to leave it alone. The 5 is going to stay. Y to the 3rd is going to stay. What I need to do is move this negative exponent and this negative exponent. So those are going to go down to the bottom and become positive. So W to the 1st, X to the 2nd. All right, we're on to number 12. So the instructions say write each expression without negative exponents. So you could try and move this down if you wanted to and then deal with the quotient. But I'm just going to go ahead and follow my product property here. Okay, I have similar bases, right? Doesn't matter if it's a variable or a number, they're similar and they're being multiplied. So I can go ahead and just combine. So this is 9. Put these together to the 0. And so that is just going to be 1. 13, similarly now just with variables. N to the A times N to the negative A. So similar bases, it's going to be N, and then it's the sum of your exponents, which would be A plus negative A. And even though this isn't a number, we know anything plus its opposite is going to be 0. So this is N to the 0, and that's just 1. M to the negative 5 raised to the 3rd. You're going to go ahead and raise a power to a power, so we're multiplying. This is m to the negative 15th. And we need to make that a positive exponent. It's going to go to the bottom. So it goes down. You need a placeholder up top. It's 1. m to the 15th. All right, this one says to simplify, and we're going to write it without negative exponents. So I'm going to start here. 32 divided by 8 divides nicely, so I can go ahead and simplify that. That's 4. I have 8 to the 8th over 8 to the 6th. Quotient rule says subtract, so it's 8 minus 6. It's positive 2. So I go ahead and I put that up top. If you use the quotient rule, it goes up top no matter what, even if it's negative, and then you move it. The other way to think about it is that these 6 cancel 6 of these, meaning there's 2 left over. And where are they left over? They're left over up top because we started with more up there. If we go to the b's, okay, this is b to the first. This 1 is going to cancel one of these. So there's 3 left over, but they're on the bottom. So I need to leave those 3 b to the third on the bottom. The other way to think about it is this was 1 minus 4. So it's going to be b to the negative third. And like I said, if you're going to use that quotient rule, that would actually go to the top, b to the negative third, and then you'd move it to the bottom to make it positive. So no matter what, it is going to end up there on the bottom. C to the third over c to the first. This 1c cancels one of these, meaning there's 2 left over, and they are left over on the top because that's where we started off with the 3. So there will be left over up there. Or 3 minus 1 is 2. All right, and that is the end of that page, 478. So we're going to go to 485. And we got 2 through 9 and 14 and 15. So we're going to start down here on number 2. So we have 5t to the second raised to the third. We have to make sure on these, since the parentheses is being raised to the third, that everything inside the parentheses, including the coefficient, receives that power of 3. And so what's going to happen is, if I rewrite this, it's 5 to the third. This really had a 1, so if you're raising power to a power, you're multiplying. 3 times 1 is 3. If you don't see the 1 there, you could also just think that this 3 attaches to it, however you want to think about it. But this is 1. Okay, the power to a power property says I'm going to multiply. Same thing here. This is going to be t to the 6th power. And if we're going to have this fully simplified, we're not going to leave it as 5 to the third because we can expand that. 5 to the third, 5 times 5 times 5 is 125, and the t to the 6th stays right there. It's positive, nothing to do there. Okay, this one, we got a lot going on. We've got multiplication, right? And we have an exponent. If you think back to your order of operations, exponents have to come first. So we need to go ahead and multiply here and take care of, not multiply. We need to take care of our exponents first and then multiply. So we're going to go ahead and bring this 3 into everything, and we'll save that 8 for last. So it's going to be 8 times whatever we get here. So this 3 needs to come to not just the x and the y, but also to the negative 7. So I'm going to go ahead and put this in parentheses so it all stays together. But this is going to be negative 7 to the third power. Now, what I want to do is I actually want to put this whole negative 7 in parentheses, just to remind myself, if I put this in the graphing calculator, that I have to expand the negative 7. So it's going to end up being negative 7 times negative 7 times negative 7. If you just put it in as negative 7 to the third with no parentheses, the 3 just attaches to the 7 and not to the negative, and your answer will always be negative. They're just going to leave it out front. Because this is an odd exponent, if it was squared, it would create a positive. But when you multiply by that third number, so since it's odd, you get that extra one, it will be negative. So in this case, it wouldn't have mattered how you put in your calculator. The answer is supposed to be negative. We do need to be careful of that, and remember to always use parentheses with a negative if you're going to raise it to an exponent in your calculator. Okay, so we still have to finish bringing in this power of 3. So I'm going to have x to the third and y to the third. Remember, these technically have ones. Raise a power to a power, you multiply. All right, if we want to, we can go ahead and find out what is negative 7 to the third. Remember, if you don't have a graphing calculator, you can still just do negative 7 times negative 7 times negative 7. And that's going to be negative 343. And then I can't forget that I'm supposed to multiply this here by 8. So times 8. And if you wanted to split that into separate steps, that's fine. I'm just going to go ahead and do it all at once. So my coefficient here is negative 2,744. And there's nothing else to do with the x and the y, so they will stay. So kind of a lot to unpack on that one. Follow your order of operations, exponents first, then deal with your multiplication. And when you bring this in, it needs to come to everything, including the coefficient. And if it's negative, make sure that negative is part of the repeated multiplication, okay, not just the 7. All right, number 4. So the first thing I'm going to take care of here is raising this parentheses to the power. Leave the 2 alone, so it's going to be 2 on the outside. Now, you could write it separately with the multiplication, but I know since these are just variables, they're all just going to attach the 2 anyway. So when I bring this in, I'm going to have my final answers there for those, and I'll just attach them here to the 2. So when I raise x squared to the 4th, that becomes x to the 8th. I'm multiplying. And remember, this is y to the 1st. So when I multiply that, that's going to be y to the 4th. So my final answer is 2x to the 8th, y to the 4th. Number 5. So here, if this was just t raised to the 93rd, it would just be t to the 93rd. And so in essence, that is what we're going to have, but we need to think about what's going on with this negative. That's the negative coefficient. So technically, that negative 93 is going to come to the negative 1 coefficient and to the t. So here's what happens when it comes to the t. But what about negative 1 raised to the 93rd? So it's a negative 1 times a negative 1 times a negative 1. Well, since it's a 1, we know that that's not going to change, right? It's not going to be a 5 or some other answer down the line. It's 1 times 1 times 1 times 1 times 1. It's going to be 1. Is it going to be negative or positive, though? This is an odd exponent. And so if it's even, the groups of 2 cancel each other out, which creates a positive. So since this is odd, you're going to have that 1 extra. So my final answer here is going to have a negative 1 as its coefficient. So we end up looking like this. Now going back to both of these, I'm going to start to get questions that say, well, you have a negative, right? Don't you have to put that in the denominator? That's a negative exponent. Negative numbers, negative coefficients, just stay, right? We have no problem with the number negative 5. We wouldn't rewrite negative 5 as 1 over 5 because those are not equal to each other. You can't just take a negative number and put it in the denominator. That's not true. Okay, so negative coefficients are fine. Don't try and put those numbers down to the bottom. We're only looking at the exponents. If the exponents are negative, we've got to adjust them and make them positive. The whole number coefficients can be negative. No worries there. Okay, number 6. I'm going to be examining someone else's work. So Aisha made a common error when she wrote 3x in parentheses raised to the 4th equals 12x to the 4th. Show where this is incorrect by substituting 2 in for x. So we're going to go ahead and plug 2 in and show that this is not equal. Then we're going to write a note explaining what she actually did wrong. So I think it helps to see what she did wrong first. So we know when we raise a power to a power, we multiply. But when this 4 comes to the 3, it's 3 raised to the 4th, not 3 times 4. So this shouldn't be 12 here. This should be 3 raised to the 4th power. But first, let's show her that this is incorrect by substituting 2 on both sides of the equation and showing that it does not come out equal if we run the numbers. So I'm going to start with my variables. I'm going to go ahead and plug 2 in here. So inside parentheses, this is going to say 3 times x, 3 times 2 raised to the 4th. And over here, this is 12 times 2 raised to the 4th. So we're going to finish this out and show that these are not equal to each other. All right, inside parentheses first, following our order of operations, this is 6, and that's going to get raised to the 4th power. Over here, we have to do 2 to the 4th first before we multiply, order of operations. So I'm going to go ahead and do 6 raised to the 4th. Remember, if you don't have a scientific calculator, you can just do 6 times 6 times 6 times 6, 4 times. Over here, 2 raised to the 4th, 16 times 12 is 192. Okay, so these are not equal to each other. So clearly, she did not simplify this correctly. So I want you to write a note explaining what she did wrong. I'm just going to show the example here. So I'm going to say this comes to here, this comes to here, which equals 3 to the 4th power, x to the 4th power, and 3 raised to the 4th is 81. So this simplifies to 81 x to the 4th. So you could write it out in a sentence, that's fine. You could also just show the correct work to her. All right, we're going all the way to number 9 here, and then 14 and 15. So 7. We got a quotient or a fraction raised to a power, goes to everything, the numerator and the denominator. So if I rewrote this and brought this in, it comes here, it also comes here. So it's 2 to the 4th over 3 to the 4th. So notice the 2 received the power and the 3 received the power. And then we're just going to go ahead and simplify that out. So 2 to the 4th, it just did 16. 3 to the 4th, we also did, is 81. And if you could simplify that, you would, but you can't. So that's your final answer. Number 8. So we have to take care of exponents first before we multiply by this 5. So you can kind of ignore it for now. Let's bring this 3 in. Remember that it comes not just to the numerator, but also to the denominator. So when I rewrite this, I'm just going to leave that 5 out front. I'm going to have to do a power to a power here. So this becomes n to the 15th. And on the bottom, this is 10 to the 3rd. And if we want to go ahead and expand 10 to the 3rd right now, we can. That's 1,000. Okay, so we are multiplying these two together. Remember that any whole number is really over 1. So when I multiply straight across here, the 5 gets attached to the n to the 15th. 1 times 1,000 is 1,000. And this would be good, but we can simplify the coefficient here with the denominator. So I can divide these both by 5. So I end up with a 1 on top, which I don't have to write in front. When I divide this by 5, I get 200. Number 9. When I go ahead and bring this in, it goes to both the numerator and the denominator. So first I need to do 19 raised to the 3rd power, which is 6859. And when this comes to the bottom, we got to be careful. You can't just attach it to the y. It would be like this whole thing being raised to the 3rd power. That's what's going on here. So it has to go to the 2. It also has to go to the y. So when this comes here, if it helps you draw it twice, it's got to go to the 2 and the y. So 2 to the 3rd is 8, and then you have y to the 3rd. And that's what's going to end up in the denominator. It does not simplify any farther. So we're going to leave that as our final answer. All right, last up, we have 14 and 15 over here. So on 14, this whole quantity here, ABC in parentheses, is being raised to the 0 power. Anything to the 0 power is just 1. So really this is just 1 times something, which we don't need to write. 1 times anything doesn't change it. So this actually just goes away. Anything with a 0 is just going to go away. So all I have to worry about is the second part here. And so first thing I'm going to do is I'm going to go ahead and simplify here. Everything inside parentheses is going to get that exponent. So it's a to the second and b to the second over a, b, c. So I have 2 a's on top and 1 on the bottom. This 1 cancels one of these out, which means I still have 1 up there. If you need to see it, it's a times a. So you cancel an a and an a. There's 1 left over. Or you do 2 minus 1 is 1, so it's a to the first. B to the second over b, same idea. This b cancels one of these, leaving me 1 on top. And this c has nothing to interact with, so it's going to stay there on the bottom. And that's your final answer. And 15. So kind of building a game plan before we jump in. Before we can combine anything here, we need to go ahead and bring in the exponents. We need to make sure that it goes to the coefficients as well as the variables. And then once we've got 2 separate things, we're going to multiply them together, okay? Because these are sitting next to each other, so we're going to multiply. So let's do this one at a time. We're going to have 2 to the 4th, which we've had a couple times now. That's 16. And then when this comes to the w, it's w to the 4th. 3 to the 2nd, 3 times 3. So be careful, don't do 3 times 2. It's 3 raised to the 2nd. That's 9. And when you bring it to the w, exponents get multiplied, power to a power. So this is w to the 6th. Now we're going to go ahead and multiply. The w times the w means we're just going to go ahead and add our exponents. So this will be w to the 10th power. And all I have to do is 16 times 9 with my coefficients, and that is 144.